Okay, Assalamualaikum and good evening. So as I promised to you, I will show you the solution of our formative assignment in the chapter 5 that I have given a few weeks before in the Google Classroom. Okay, so the question is you have to consider fully developed coordinate flow. So doesn't mind what is the name of that flow because it's just the name of that flow. It not really matters to your solutions here. Okay, and then flow between two infinite parallel plates. So this one is the parallel plate, one up and one down below, separated by distance. The symbol of H here shows in the diagram. With the top plate moving, the plate here moving to the right side, and the bottom plate stationary, so it fits here. The bottom plate is fixed, so the only that move is the upper plate. The flow is steady, incompressible, and two-dimensional in the xy plane. Use the method of refitting variables to generate a dimensionless relationship for the x component of fluid velocity u. So one of the variables here, fluid velocity, as a function of fluid viscosity mu, top plate speed v, distance h, fluid density rho, and distance y. Okay, show all your work. So it's already given here the answers for the final relationship. Okay. Okay. So the repeating variables that we have right now is already given in the question. We have to find the u, this one, the relationship, as a function of. So you put it f, the bracket of the function of viscosity mu, speed v, distance h, fluid density rho, and distance y. So 1, 2, 3, 4, 5, and 6. Okay, so right now we already identified there are 6 repeating variables that we have to consider in our repeating variables method. Okay, so we just put it n equal to 6 because there are 6 variables, and then so we list down u, mu, v, h, density, rho, and y. Okay, so the dimension of the velocity, L over time, right? Length over time, or distance over displacement over time. So L t minus. Okay, so this is the dimensionless for the u, and then for the viscosity, m, L minus 1, k, t minus 1. For the v velocity, also similar to the u, the same dimensions, L, t minus 1, and h is just L. For the density, we have mass over length over 3, so L minus 3. And y is also the displacement, so just put it L, length, dimensions for y. Okay, so as for the first guess, 1, 2, 3. Okay, we put it for the first guess, j we have to set to the number of 3, so we only consider the first 3 dimensions there, and So number of expected pi theorem is equal to the symbol we put k, right? Okay, k equal to n minus j. So we have the sixth number, six, the value for the n, and j, the first guess here is 3. So we consider 3 Buckingham numbers. Okay, so k equal to 3. Okay, we need to choose the 3 separating. Wait a second, I have to. Okay, so right now we choose only 3 from these 6. As mentioned in the rule of repeating variables, we try to avoid the viscosity here. So we choose the uh, what we call the fixed length first, and velocity and density. Okay, why we choose the velocity? Because we have to choose either the u or v, because it has they have the same dimensions here. And why we choose the h instead of y? Okay, because y uh there will appears in every pi Buckingham, and then for the h it is a fixed value, so it is desirable to choose the fixed variables here. Okay, otherwise the y here will appears in every Buckingham that we try. Okay, so we choose 3 of them, density, h, and the v, velocity. Okay, so this is so we list down what we choose: v, h, and density. Okay, so for the pi one, okay, we put u, v, because it is the function of u, v, density, okay, and h. Okay, and then you put exponent of a, b, and c. Okay, and then we list down the dimensions. Pi 1 equal to for the u, lt minus, and then for the v, lt, also lt minus, but with the power of a. Okay, and then for the density, the m, l minus 3, the power of p, and finally the h, which is only l, c. Okay, okay, so right now we have mass, length, and time. So we put it here: mass m power of 0 equal to how many mass here is only in the density. So m to the power of p, so we put m p there. Okay, oh, I forgot to put number 1, p1, c1 because of the pi 1. Okay, so So now we straightforward, we have b1 equal to 0. Okay, and then we have to find the time. So right now we have time equal to the power of 0 equal to 1 is t minus a1, and that's it. So t0 equal to minus 1 minus a1. So you will get 0 equal to minus 1 minus a1. So a1 equal to minus 1. Okay. Put underline over there to make sure you do not miss that information after this. Okay, and then we have length. Okay, so length 0 equal to we have 1 here, so L, and then L A, the power of 1, and then we have here L minus 3b1, and finally L the power of c1. So it's more complicated. So 0 equal to this one 1 plus a1 minus 3b1 plus c1. So we have substitute all the information that we have for the value of b1 and the a1, and then 0 equal to 1 plus a1 is plus minus 1 times 3 b1 is 0, so this one can be cancelled off, so just 0. And then c1 that we have we are going to find right now, right? Okay, so 0 equal to 1 minus 1 minus 0 plus c. Okay, so 1 minus 1 is 0, minus 0 is 0, so c equal to 0. Okay, so the okay, okay, so now we substitute into this, so you will get h is equal to 0, so we eliminate the h, and then b also 0, so we eliminate also the density there. So relationship right now will be pi1 equal to u v minus 1, right? You substitute into this, so you will get that like this. So if we rearrange that, we will get u to the over v. Okay, that is our second dependent pi, we call it dependent pi. And then we consider this for the second pi. So pi 2 will be u over v. Okay, so yeah, we have to break a little bit. Okay, so now we are going to the pi, the second pi here, and then we have sorry. So our pi 1 now, I use the blue one. Okay, pi 1 is u over v. Okay, so for the second pi, okay, pi 2, we use the density, viscosity mu to substitute into this. We have to consider next variable that we left behind. Okay, so right now we are left with the viscosity and the y. So we have to use we have to find the relationship between the viscosity and our other variables. So we have to consider pi right now. So pi VA density B, we put it 2 and H2 C2, sorry. Okay, so we put it res respective dimensions. So for the viscosity here, the dimensions for this viscosity is mass time minus 1L and the time minus 1. And for the V, we have L T minus, so we put it A2. And then for the density, M L minus 3, B2, and finally our H, which is dimensions of length L, so we put C2. Okay, so the same uh, repeating variables, the same methods that we have done in the pi 1, we do the same in the pi 2. Okay, so let's find the mass first. Okay, so m0 equal to 1 is in the viscosity, m1, and here no, and then we have in the density, so times m b2. Okay, and here is also no mass found here. Okay, so 0 equal to, this is 1, so 1 plus b2, so you will get b2 equal to minus 1. Okay, and then for the length, L equal the power of 0 equal to, here is length minus 1, and here is length to the power of A2. Here is the length the power of minus 3B2, and here is length to the power of C2. Okay, so you will get 0 equal to minus 1 plus A2 minus 3B2 plus C2. So we cannot solve these equations because we just know the value of B. We do not know the value of A. Okay, A and C. So we skip first. We go to the time here. Time T equal to the 0. Here is minus 1. And here is T the power of A. So A minus 2. Here we don't have T, and here also no T. So finally we'll get 0 equal to minus 1 minus A2. And then you will get A2 equal to, we put it to the left side. So A2 equal to minus 1. Okay, so we substitute here into this, and then B2 here into this. So we can solve the C2. Okay, so 0 equal to minus 1 plus minus 1, 3b minus 3. B2 is minus 1 also, and then plus C2. So you will get minus 2 plus 3, right? Oh, sorry. This is minus 2. Plus 3 and plus C2. So you will get C2 equal to minus 1. Okay? And then we put it back into this one. So the pi 2 now will be viscosity times V. V is the A2 minus 1. density is B2 is also minus 1, and finally the H C2 here is minus 1. So relationship right now for the pi 2 will be viscosity over V rho H. Okay. Okay, so that is for the pi 2. We have to repeat this method until the pi 3. Why? Because we calculate here the number of expected pi is 3. 6 minus 3 is 3. Okay. So we repeat the same thing for the next pi. So we have pi 3. So the pi 3 here will be considered the other variables that we left behind. So right now is only y. We do not consider, right? We have done with the u, we have done with the viscosity, the mu right there. And now finally we have to consider the y. Okay, so you put y, v, rho, and h. So the same step, you put it here is a3, b3, and here is c3. Okay. Okay. So right now pi 3, we put it their dimensions. Y is L, and V is LT minus. So we put it here A3. Density is ML minus 3. B3 there. And then finally our H, which is only length L. So C3. Okay. So the same steps, we have to consider only 3 variables, mass, length, and time. So we put here is the mass first. So M0 equal to only MB3. So we will get B3 equal to 0. Okay. And then for the length or time first, time is 0. Here we don't have any time, and then here we only have in the velocity. Okay, so the time here is minus a3. This is one of the minus time a3, so you will get the a3 to the power of a3 minus a3 there, and then the a3 also equal to 0, right? Okay, finally our length. Okay, L0 equal to, right now we have 1 here in the y, in the variable y, and L there, A3, and here is L minus 3B, 3, and finally L C3. Okay, and you will get 0 here, and then this one is 1 plus A3 minus 3b3, and finally plus c3. So you get 0 equal to 1 plus a3 minus 3b3 plus c3. Okay, so right now we already have known that b3 and a3 is 0, so we cancel off a and b, so you will get C3 is equal to minus 1. So we substitute back into this equation, this pi 3 equation. So you will get pi 3 y, and then v we have a minus, so there is no v, and density we have b3, so b3 is also 0, so we don't have density, and finally we only have h. So h is c3 we substitute with the power of -1 there, so you will get there. So pi 3 is y over h. Okay. Okay, so relationship between the final relationship or okay between pi's, you have to check with the tables uh, of the formulas that we can refer. Check your notes that here is the Reynolds number, right? So finally we will have to write that the function of pi 1 equal to the function of pi 2 pi 3, right? So this is we are going to write. So pi 1 there is u over v. So u over v equal to the functions of, okay, pi 2 here is the Reynolds number formula. Okay, so if you don't know the Reynolds number, I think you have problem with the mec241, right? So make sure you already know this formula. This is the Reynolds number formula. So you can also write down back there. Let's say you forget that this is the equation of the Reynolds number, so you just copy down this one, mu over v rho h, mu over rho v rho h, and then the final pi here is y over h. So this is our final answer. But if you can write down the proper way, you substitute this one with the another names of its formula. This is just the Reynolds number formula. This is much better. Okay. So finally, our answer is the same as the answers given in the question. Okay, so that's all for this video. I hope you understand now how to solve this problem. This is a repeating variables method using the Pi-Van-Kilhelm theorem. And make sure you study a lot, you do the exercises, and try to answer the past year questions. You can download from our library database, and then that's the tips to score the exam papers in UiTM. You have to do a lot of the exercises by answering past year's questions. Okay, so good luck. Sorry, and thank you. Okay, bye bye.